You want to introduce us, Xing, or just start?
Oh, I think we can
It's
just
fine.
start. So this is
Yeah, yeah, yeah.
okay. So we are going to discuss the CSI controller get node info design. So Eddie, you want to go ahead and share your screen?
Yep. Just wanted to check first. Can you guys see my screen or is that not?
No, right now it's blank. Maybe
Yeah,
you're
you're
not
sharing the
here
wrong
in the.
screen.
Oh yeah, now we
Okay.
can see. Okay.
Okay, cool. Um,
This is the same doc that's in the chat, right?
yeah, it's the same one. So I seeded a quick doc with some context, as well as like a brief overview of the proposal. I also see Sunny join. So I'll quickly go over this and then we can just jump into discussion. Um, I've picked out five, I believe actually four topics that I think are really important, that we need to drive to a conclusion. If we can even get one or two in this meeting, that's great progress. So it's okay if we don't get through all of them. If somebody has a even more important topic that they would like to bring up, let me know. We could just jump into that instead.
Okay.
So, yeah. So for a little bit of context, the current CSI NodeGetInfo RPC returns three things from the node plugin, and that's the node ID, accessible topology, and max volumes per node, where the last two attributes typically require cloud API calls. So this today forces drivers to either distribute these cloud credentials to every worker node, or what we really do in practice, a lot of providers, and I'll demonstrate that, is we just maintain a hard-coded table. And we also have static flags that let users override these values, and so on and so forth. So for the EBS CSI driver, we have this hard-coded table uh, where we map a specific instance type to um, how many attachments it can support. Um, and every time a new instance type comes out, right, we go update this table and generate a new release, so that the user gets that value correctly populated on their CSI node object. And then Azure does something very similar. They also have a hard-coded table of values, uh, where they basically follow the same strategy, and same for GCP as well. So that's what a lot of plugin authors are doing to sort of work around this issue, right, and not have to retrieve that info in Node and distribute cloud credentials. So,
Sunny has a question in chat.
oh yeah. Uh, Sorry, I'm not able to see the chat right now.
So she's asking, is there no public API for Azure and AWS for attach limit?
Yeah, there is. So uh, for Azure, I'm not sure. For AWS, we have describe instance types, and that's what we use to populate this table nowadays. We have a script, right, that we will run locally before doing releases, and then we'll use the public API to basically generate this information. And I believe Azure also has similar uh, public API. I'd have to double check that, but I think I recall. Um, but yeah, so in terms of the proposal, right, what we're trying to do here, and who's also on the call, right, is we're proposing two new alpha RPCs that split this node registration into a cheap node side identity call to get the node ID, which we don't need cloud credentials for, and then a separate RPC to retrieve that information as well as max volumes per node from this controller RPC. And a key insight of this proposal is that the scheduler, we're not changing any of that behavior in Kubernetes. It'll continue to read the same CSI node allocatable count field. So we're essentially just shifting the writer of this field, going from kubelet, which is what calls the node get info RPC to get that, to the external attacher for drivers that opt into this behavior. And so as a brief overview, right, the idea would be that kubelet will call nodeGetID instead of nodeGetInfo, store this result in a new annotation on the CSI node object, and we don't touch the spec drivers allocatable field. The external attacher is watching the CSI node, sees a new annotation added, calls the controller get node info RPC, does a bit of work, and for this we'll discuss in a later topic, and writes the spec drivers field with this topology and limit info. And this we're not changing, but right scheduler will continue to read the field as it does today to make scheduling decisions. And then the KEP also goes into this detail. It utilizes the mutable allocatable count. So for drivers that opt into this new capability, we would have the kubelet refresh logic shift over to the attacher as well. So I think we have clarity on these pieces, and we
Okay, can I interrupt here?
yeah.
Yeah, so I was here for the earlier discussion last week when we were going over this proposal and trying to think through the implications of it. And I've been thinking about it since then. And I want to question some of the basic assumptions here because, well, I want to commend you for like a very complete, well thought out design, but like the design is still very complicated and that makes me uncomfortable. And so I was thinking about like, what are we actually trying to do here? So I'm going to let me think through like the basic problem out loud and tell me if I have any of this wrong. So what we're trying to do at a high level is manage a scarce resource, which is limited number of attachment slots between nodes and volumes. The original feature when we designed this years ago assumed some sort of fundamentally static number that was easy to compute, easy to know. In reality, this number is hard to compute and hard to know. And in Weiwen's version of this, it's sort of fundamentally unknowable, right? Because we have to account for actions taken outside of Kubernetes and the CSI plugin, right? Other things could have mounted volumes that could have taken up your attachment slots. So in some sense, no matter what we do, we will sometimes get the wrong answer because the actual correctness can be influenced by things outside of Kubernetes. Is that correct?
So that is correct, but
Okay.
yeah.
All right. And then I was going to say, so if we're trying to measure this resource that we fundamentally can't really know whether the number we have is correct, and we already have a built-in mechanism to handle when we get it wrong, right? So if there's a race between a new pod getting created and some external thing stealing the slot that pod would have needed to attach to its volume, there is an error message that we can return that causes the system to notice that and retry appropriately. So like we already have the basics of like a way to get correctness without having any limit at all, right? You could just be greedy and keep trying to attach until you get the error and then stop. That would be a workable system. And so in this world, the limit number that we're calculating and sticking in the node object is really just an optimization to prevent hitting that error too often, right? Basically giving hints to the scheduler saying, hey, we're probably going to run out of slots around 24, whatever the number is. So stop trying to get new slots. But in reality, it might be lower, it might be higher. It depends. And we're building this complex machinery to basically make that estimate a little bit more accurate, but not 100% accurate, just better, right? Is any of that fundamentally wrong?
So I don't think it's fundamentally wrong because like you're right? Like we always have that open question of like, what happens if somebody manually attaches a device or an
Yeah,
ENI or something like outside of Kubernetes, right? Like how could it know?
yeah.
The idea though is that right, like we do want to continue to work towards the desired state and having accurate information. And
But I guess in my mind, I'm thinking, what if we took an entirely different path to get the accurate information? What if we made the resource exhausted error the definitive signal that, hey, you had too many? And we shifted the responsibility onto the CO to like notice when it got that error, to stop creating new attachments, and then not to try to create any new attachments until someone had detached something. Um, that would just sort of be like a empirical. I mean, this is sort of like how network protocols like TCP determine what the window size is, right? Like you just try more and more and more until you hit a limit, and then you end up with a system which is very flexible. If you just keep trying to attach until the system says, okay, I can't take any more attachments. I I feel like that might be simpler to implement, um, and more flexible ultimately than this very complicated mechanism of like calculating numbers and passing around attachment lists and comparing attachment lists and calculating numbers and storing those numbers and then still being open to rare race conditions where the number you calculated wasn't right. I don't like how much new stuff this puts into CSI to basically just make an optimization a little bit more efficient, which is how I perceive this whole feature.
Yeah. So for that proposal, I think the scheduler will need to maintain a estimation of how many attachment is available, right? So
Right,
that is basically similar to the window size estimation for the TCP.
right.
Yeah, I think that would be maybe more harder than this proposal. That estimation is also very hard, and it has less information available. It only has an error code.
Well, but I consider less information available to be an improvement, right? Because this current design involves passing a whole bunch of information back and forth between the CO and the SP, um, and that makes CSI very complicated. And I'm imagining for a lot of CSI plugins, like none of this is going to matter, so they're going to ignore it all. I was just trying to think through the lens we usually take when we are looking at a CSI design is we Kubernetes is only one possible implementation of something that might consume CSI. So we try to ask ourselves, what if we were trying to design some other CO that had to consume the CSI API? Like, what would it do? And how would we write the documentation in a neutral way that would make sense to any CO, whether it's Kubernetes or not? And it's very hard to figure out how to write that. And people would ask, like, why did you design it this way? Because it seems very complicated to get it to basically solve this problem of, you have a limited number of slots, you don't know how many there are, but at some point you're going to run out. And this whole limit mechanism is just a sort of a hint that says you're probably going to run out at around X, whether that, and we'll tell you what X is. Um, but you still need all the other functionality to handle when you're wrong. And I don't know. That's my basic level of uncomfortableness with this proposal is that it's it's a lot of new CSI code, a lot of new RPCs, a lot of thinking through the backwards compatibility stuff, as we talked about last week, is it's going to be messy because you can't not support the old way of doing things. You're going to have to support both at the same time, and that's also kind of messy. Um, and all we get at the end of the day is the estimate's a little bit better because it can still be wrong.
Yeah, those are fair callouts. I think that some of those problems, like the compatibility, definitely are a headache to think through, but they are soluble. In terms of the overall design, though, I think one thing that it's kind of like worth noting definitely is that I think a little bit more than just data freshness. It's more so like correctness of the data to begin with. Because one big problem, right, like as I mentioned here, that providers are basically maintaining these hard-coded tables today. Um, and so, you can every time there's basically a new instance that comes out, we have outdated plugins that don't account for that.
Right.
So, right, like the values are just non-existent, and it's yeah, it's a little hairy, especially because
Yeah, I'm not saying I like the status quo. I'm saying that the status quo seems pretty bad because it forces us to run on this treadmill of updating these tables forever. And I was thinking, what if we stopped trying to have a table that had the correct number for every instance and just made Kubernetes smart enough to learn it empirically by making attachments until I can't make attachments anymore, and then recovering, and then remembering where it hit the limit. Like that then you just get correct behavior for free everywhere. And yes, it's a lot of work on the Kubernetes side, but like it makes everyone's life better. Um,
yeah,
and
I mean,
that seems like a better endpoint, even though yes, there's a lot of work to implement it correctly.
Yeah, I think this is really hard for today's Kubernetes because Kubernetes scheduler actually don't will not fail when the attachment is running out. Yeah, it will still schedule the pod, and then Kubernetes will fail that pod, and higher level controller will need to delete this pod and create a new pod. Then it will try again. This is a long loop cycle.
Okay, so you're saying even today, our mechanism for handling when we get the number wrong is actually not that good. If you're saying it works, but it's slow and clunky, and that's why we're willing to expend all this effort to optimize not getting that error case.
Yeah.
yeah,
And with this very long cycle, it will be more harder for the scheduler to actually calculate this
So,
limitation.
well, I'm asking, can we fix that? Because this is like this is the basic problem that I'm seeing is that we're trying to manage this resource that is fundamentally unknowable. And you're saying when we get it wrong, we we have a really high penalty. So we spend a lot of effort trying not to get it wrong by having this limit. But the limit can still be wrong in rare cases, and we still are going to hit this.
Uh, Actually, it's not that easy to get wrong. Okay.
Yeah, I agree. Like it would require someone to try to attach a volume
Yeah, yeah, yeah.
on
And that is not
on a running
everyone
instance.
doing daily. Yeah,
It's pretty rare, but I mean, it, a lot of CSI plugins don't have this problem at all. It's
yeah,
really just a strange thing that happens in hyperscalers, I guess. Um,
yeah. I think
so I'm
one use case that kind of keeps coming back to mind with this approach of just trying to empirically figure out the right value is one of the most common ways that users will use the driver in scale up scenarios, like when they have Spark workloads, and you have Carpenter spinning up many new instances, you have the scheduler at that point, presumably trying to figure out what the right attachment is. So there's like, I don't know, say 250, 300 pods in the queue. It's going to send them all to a node. Like 100 of these pods are going to get stuck because there's no slots for them. So then, like who mentioned, we have to tear down all of these resources and find an appropriate place where we can put them. That's a lot of work and adds a bunch of latency.
Yeah, I agree that the current design is very bad. There's a lot of things about Kubernetes, especially related to like attaching storage, that are kind of clunky and bolted onto the side and not close enough to the core to have been done right. So I just, my preference is like if attachment slots are such a fundamental resource that matters to the scheduler at the end of the day, there should be a more straightforward way for the scheduler to get access to them. Like maybe node volume attachment slots need to be some sort of like a first class resource, or there needs to be some way to directly reserve like attachment slots through CSI that says, hey, I want to attach this volume to this node. So like, go tell me if that's going to work in advance. And then the node actually like reserves something, where it's making you a promise that if you try to claim that attachment slot later, you're going to have it. Something like that. Because that's easy to understand. This current design where like when you ask how many, or when you call the node get controller get node info to get the attachment limit, you have to pass in all of your current attachments. That just seems really gross. And I'd like a more straightforward way to get at what we're trying to get at, which is like, I want to know in advance if I try to attach a volume, is it going to work, without actually trying to attach it and then finding out it didn't work, right? That's what we're trying to do, is avoid the case where you've already scheduled the pod and there wasn't a slot for its volume. And so now the pod is going to be in a failed state. You'd like to just know in advance. And the way we've done it is by calculating a number and the scheduler doing some math. But I'm thinking there's got to be a better way at the CSI level, for the CO to basically ask, hey, can I attach one more volume to this node? Is it going to work? And the node plugin can say, yeah, that'll work. Or the controller plugin, or whoever has the information.
Yeah. I have a question, Ben. If you could wave a magic wand, right, where would ideally this max volume and topology info that we currently use the node RPC to retrieve it, should it be a node or a controller RPC? Because today, right, it's a node RPC, but the only consumer of this information is the scheduler, which is a controller component. So we have all this plumbing to do. Right, in the mutable CSI node cap, we have kubelet calling a driver's node get info, updating that value for the scheduler to retrieve it. There's nothing else consuming that. So,
Right.
like a kind of just challenging the existing implementation. It's like,
I'm pretty sure the existing implementation is the way it is because not all SPs even have controller plugins, and they still want to be able to enforce volume limits on those. So there needs to be a way for node-only SPs to have a limit if one exists. And then, I guess there was this assumption that like the node knows more than the controller about its own limits, which turned out to be false. I mean, or at least false in some cases. There could be situations where, the nodes still does have more information than the controller, where the thing limiting the attachments could be extremely specific to the node, and the controller knows nothing about those details, and only the node knows. So there needs to be a way for the node to say, hey, actually, I know that my limit is 10, and when the controller might assume it was higher. But then we have this case where the thing that knows is something that you need an API token to get to, and we don't want the node to have that API token, and so it's better to go to the controller. Like the most flexible implementation would ask both the node and the controller and pick the lower of the two numbers. That way, both sides could get a vote, and anyone could implement any kind of limit, or to do like I said and just keep trying until someone says you don't actually have any more slots, and then remember what number you were at when you hit that point. That's the other really flexible way of doing this. I think if I could wave a magic wand and redesign this, I think I would have a way for nodes to register. Like I would have more support in CSI for the node to get information from the controller plugin, like with some sort of a node context type of object, similar to volume context or publish context, where the controller gets to hand some information to the CO that then gets handed to the SP or handed to the node side of the SP, to when we ask this question of what is your attach limit, if some sort of a registration mechanism where the node woke up, had an ID, somebody went back to the controller and said, hey, can you just populate a node context object for this node ID? And it did. And then that got passed down to the node when we ask these kinds of questions. Then that would be a channel for controllers to pass arbitrary information to each node. That would be more flexible than this design, which is very specific to these two fields, the topology and the attach limit. But I'm sure there's downsides with that approach too. I haven't had time to think through them all.
Okay. Yeah, this is really good feedback. We can explore that a little more. I think one thing that's kind of been on my mind this meeting too is that maybe we're kind of trying to boil the ocean here a little bit, as in like, right, like today, I don't think there's anywhere in the spec or even in Kubernetes that says we have to support out-of-band attachments. So that's just something that we are kind of assuming here, or basically adding support for, right? Like we know that drivers have already been doing this on a best effort basis.
Yeah.
But it's not.
Yeah. I mean, the spec can't talk about out-of-band attachments because they're fundamentally not related to Kubernetes or CSI, right? So they're invisible to us.
Right. Yeah. And so it's something probably that has no clear definition, right? Like what should the behavior be? And
well, that's why I like the iterative, wait for an error message kind of implementation, right? Because then you get correctness for free. But the downside is, as you said, currently the way we handle that error is horrible, and that's why we try so hard not to ever hit it. But if we could fix that problem, then we'd be in a better shape. Then we could just sort of feel towards where the limit is and not pay a big penalty when we actually hit the limit and have to correct.
Yeah. And for that way, if for example, if we have a new node and we don't get any information for this node, and we have thousands of pending pods, then we are facing the problem that how many pods we are going to try for this unknown new node. Maybe we will need to.
Well, I like the idea of having some sort of a loop in the scheduler where the scheduler can say, okay, I've got 300 pods I want to schedule to this brand new node. Like, go start to try to reserve 300 attachments from the node. Like, say I want an attachment, yes or no. And they call that in a loop, and it will hand out attachments until it can't hand out attachments anymore. And then the scheduler will say, oh, okay, I've hit the limit for this node. So like you could solve it at some level by just making explicit the fact that these attachment slots are a managed resource that needs to be accounted for. Like it's all invisible right now. And we're just doing some math to try to account for it. But you could make it explicit and say this is an actual thing that you need to reserve. And if you can't reserve it, then don't try to schedule a pod there.
Reserve that, but we, as cloud provider, we don't have something like some
No, no.
API.
I mean, I'm envisioning some sort of a new Kubernetes API object, which is like a node attachment slot, which you would have to like, claim, and there would be machinery on the node side to say like, yes, you can have more slots, or no, you can't have more slots, and that's how you would discover. I mean, that's also a pretty complicated design that would be a lot of work. So I'm not saying that we should do that. I'm just saying that is like a way forward, is to make this explicit and make represent the object in the API directly somehow. Because you don't just want to throw all your pods in a node and then find out that only 10% of them landed.
Yeah, that
90% have to get rescheduled.
API calls. So I think this try and back off policy will make both sides more complicated, right? So for the CO, it will need an complicate algorithm to estimate the limit, and that will be even harder for many parallel pod being scheduled.
So I agree this is all complicated, but as long as we have the stance that like you can still at the end of the day be wrong, and you have to, which is why we have the whole thing for passing in a list of attached volumes, and so the SP can figure out like which ones of those are from Kubernetes, which ones are not from Kubernetes. Like that whole part of the design is the part that's really bugging me, and it's because it's trying to solve this problem of like there's other things competing for the resources that we have to somehow account for that. And
yeah, and if we don't consider the out of band attachment, then these IDs will actually provide us the most accurate information. That is absolutely accurate if we don't account for out of band.
Right, like that's a good point, and what I was thinking about earlier, which is that, right, if we remove this supporting out of band attachments from the current proposal, then right, it kind of removes the big problem here of having to pass around publish volume IDs and all the ugliness that comes with that. Right, it's basically shifting or providing drivers the ability to query the info they would get on the node, but on the controller.
how is that? Help me understand that. Doesn't the controller get controller publish calls, so it knows what Kubernetes thinks is published?
Right, but it doesn't, like, to get a allocatable value, the only way you can do that today is by calling NodeGetInfo.
No, right. So what if there was a way that you could get this from the controller side, from a node ID? Because that's just working around the fact that the node doesn't have this appropriate security token to talk to whatever API has the right answer. So if you move that to the controller side and you just call it on the controller with the node ID, that solves the security problem. Could you get the right answer without passing around all the published volumes? Or what
we
would
still
break?
have to pass around these volume IDs, but that is an accurate answer, and that is not a guess. Yeah. So why we only able to do this at controller side is that it is the controller that calls node no I think controller publish volume. Yeah. So the controller publish volume will have a race condition with this published volume IDs. So we have to deal this at the same component that calls controller publish volume.
So I agree that there's a race, and that I understand why you would want to make the call from the same sidecar that calls controller publish volume, the external attacher.
Yeah.
But why would you need to pass in a list of published volumes to that, or would you not? Am I
Because
missing some?
even if we don't have any out of band attachment or detach, and we still have some static slots being taken by some unknown volume number of volume. For example, an user may configure some static disk attachment on the node pool or some static settings.
Right. We talked about that, and like that's the basic problem, is that like CSI can't see that, Kubernetes can't see that.
Yeah.
It's very hard to
But
like
that is
explain.
static.
Yeah. But it affects the limit.
Yeah. So
And
if we count this limit once, and we will have the accurate number for all the life cycle of this node.
and we can't do that without the list of attached volumes being passed in.
Yeah.
Like I guess I'm questioning why the SP can't have that information on its side through some
Yeah.
other mechanism. Like because every one of those attached volumes, there was a controller publish volume call. So like we could just say the SP just needs to remember those calls, and then it knows what the attached
Yeah.
volumes are.
Yeah, actually, there's some of the volume is not published by the by CSI. Actually, that is configured from the node pool, and which is
Those are the static ones, right?
yeah.
But those would also not be passed in by the CO in this proposal, right?
Not yeah.
Right.
In
So
this is a
the only
task
ones the CO can pass in are the ones that it knows about, which are the ones that were published.
Yeah.
And what I'm saying is,
I mean, yeah,
you
in
already
this
have that
proposal,
list.
I'm returning the published volume IDs from the SP to CO. Yeah, so SP is describing is querying what he think is attached and return this list to CO.
Okay, wait. I'm gonna have to find this in the doc. And I'm gonna get kicked out of my conference room in 3 minutes because I can only get this room until 1 o'clock.
Actually, so I need to drop at like in 4 minutes. Can I? So add your co-host. If you become a host, will you be able to just finish the remaining of the recording? That's okay. It's going to be like 2 recordings.
Yeah, that's fine.
Maybe let me just make you a host right now. Ben, maybe I'll make you also a co-host this way.
Oh boy.
2 co-hosts.
I'm on the web client and the phone client.
No.
I
I don't know
don't
which
have a real
one.
Zoom client.
You have 2. Okay, I'm not sure which one.
Yes.
I'll make both.
Make Eddie the host. Don't make me.
I'll make
all
you
screwed up.
both co-hosts. Okay, I will change Eddie to be host. Ben, you have two of your co-hosts. I'm not sure. Okay, let me make host. All right.
Okay, I'm looking at the
maybe
CSI proposal.
I'm going to stop recording now, and then maybe Eddie, you can see if you can start recording. Okay, so this way we have 2 recording. Stop.
Yeah.
I will
Okay.
stop. Stop recording.